For Panchami, real numbers has done in school, right? What about Shreya?
No, ma'am, they have not started yet.
Okay, Shreya, tell me which textbook, yours is a revised or what? Old textbook,
Ma'am, it is revised, ma'am.
revised textbook. Okay, do you have textbooks with you? Both of you?
Yes, ma'am.
Okay.
Yes, ma'am.
So let us start with real numbers. Okay, already I have explained in bridge course what are the types of numbers. Right now, once again, we'll recall all those things. First one is natural numbers, right? What is next after natural numbers?
Ma'am, whole number. Whole number.
Whole numbers next.
Ma'am, positive and negative numbers.
Positive and negative numbers are called integers. After integers?
Ma'am, rational number.
Rational numbers. They are denoted by the letter Q. Then?
Irrational number.
Irrational numbers. Then real numbers. Okay. So what are, what are rational and irrational numbers right now. So what are rational numbers?
Ma'am, the numbers which can be put in the form of P by Q where Q is not equal to 0.
Very good. P by Q where Q is not equal to 0. Okay. What are the difference between rational and irrational numbers?
Ma'am, rational numbers can be put on the P by Q, but irrational numbers are...
Cannot be okay. We cannot express in the form of P by Q right now. Means terminated or non-terminated right now. Terminated, but what is the condition here? Non-terminated, but
recurring.
Recurring. Very good. So they are recurring, but irrational numbers are non-terminating and non-recurring. Right now, you know which are irrational numbers. Can you give example for irrational numbers which cannot be expressed in P by Q form?
Ma'am, root numbers.
Root numbers. What about root 4? Is it irrational number?
Ma'am, like root 5.
Okay, they're not perfect squares right now. So root 5, root 7, root 2, root 3, which should not be perfect squares. Okay, if it is perfect square, we write the number right now. For example, square root of 16, we write it as 4. It becomes a rational number right now. So these are non-perfect squares. Understood, Shreya?
Yes, ma'am.
Okay, so these are all irrational number. What about real numbers?
Both rational and irrational together are called.
Very good. Both rational and irrational numbers are together called real numbers. Very good. Okay, and already I have explained what are prime numbers and the composite number. Let us start with fundamental theorem of arithmetic. So what is a fundamental theorem of arithmetic? See here, fundamental theorem of arithmetic says any natural number can be written as product of its prime factors. You know what you mean by prime factor, right, my children? Prime factors, prime numbers means here which are prime numbers. See, 2 is written as 2. 4 is written as 2 into 2. Right now, 253 is written as 11 into 23. Here 2, 11, 23, all these are prime numbers, prime factors, right now. So any natural numbers, take any number, okay, we can express them as the product of prime factors. I will show you that. See, here's one second. Yes, Carl Friedrich Gauss. He was a German mathematician. So he has contributed for in the field of maths and science. Okay, fundamental theory of mathematics. See, every composite number can be expressed or factorized as product of primes, and this factorization is unique apart from the order in which the prime factors occur. Okay, so you know Euclid's Elements right now has written one book. Okay, Euclid. See, already it was explained. This concept was already explained in Euclid's Elements. Okay, but the first correct proof was given by Gauss. Okay, in his the book Disquisitions Arithmetica. Okay, so this concept was given in that book, but before this concept was introduced in Euclid's Elements. Okay, did you understand what I'm saying?
Yes, ma'am.
Okay, one second. I'll show you how to write the. Yes, for example, 14. See, you know how to you have to write 14 as the product of prime numbers. Okay, so divided by prime number. 2 is prime number, 2 sevens are 14, and 7 ones are 7. 14 can be written as 2 into 7. Right now 14 is composite number. We are by using prime numbers, we are writing this right now. 2 into 7, where 2 and 7 are prime numbers. For example, 26. How can you write 26? 26 is even number, composite number, right now, divided by 2, 2 ones, 2 threes. And 13 is prime number. You can write it as 2 into 13 and write 35. How can you write 35? Tell me, by using prime numbers. Shreya, Panchami, how can you write 35?
5 into 7.
5 into 7. See, 5 and 7 are prime numbers, right? No. So 5 sevens are 35. How can you write 48? Shreya, are you understanding what I'm writing?
Yes, ma'am.
How can you write 48? If you don't know to write directly, you can use prime factorization method. 48. It is even number, so divided by 2. 2 2s 4, 2 4s are 8. 2 1s, 2 2s, 2 6. Next 2 3s, 3 1.
3 1.
Yes. How can you write this? 2 into 2 into write 4 times into 3. See, all these are prime numbers, right? No, see the composite number for every composite number can be expressed as the product of primes. That is what fundamental theorem of arithmetic. Got it? Understood? If you have any doubt, there itself you can ask me. Okay, no problem. Did you understand this theorem? Yes, sir.
Yes, ma'am.
Panchami?
Yes, ma'am.
Yes. For example, 141. How can you write 141? Divided by 2, 3, 4s are 12, 7s, right now. So 47 is prime number, right now. So 41's 47. So 47 into 3, 3 into 47. Okay. So like this, every composite number can be expressed as the product of prime numbers. That is what fundamental theorem of arithmetic. And shall we go to the exercise?
Yes, ma'am.
Yes. Exercise 1.1. Express each number as a product of its prime factors. First one, 156. Yes, how can you write 156? So it
Ma'am,
is even, sorry?
Ma'am, 2 into 2 into 3 into 13.
Okay, 3. You got 3.
3.
Okay, let me check. 156. Oh, second one. Okay, sorry. First one is 140, no? First one is 140, sorry. 140. So 2 sevens, 14. 5. Next.
Ma'am, it is 2 into 2 into 5 into 7.
Very good, very good. 2 into 2 into 5 into 7. Okay. So you had to write in terms of prime numbers. That's it, children. So if you can write it as 2 to the power of 2 into 5 into 7. And second one, 156. This Panchami already told the answer, right? 2 sevens, 14. 2 8s, 2 3s, 2 9s. 39 is divisible by 3, 1, 3, and 13. Right, children? So 2 into 2 into 3 into 13. See, we are writing as product of only prime numbers. Okay. Okay, will you do the next one? Next one is 3825. Do it fast, children.
Ma'am, it
Yes.
is 3 into 3 into 5 into 5 into 17.
Very good. 3 into 3, 5 into 5 into 17. Panchami got the same answer?
Yes, ma'am, got the same.
Very good. Okay. So no need to explain this, right? Shall I give one more? 5005. Yes.
Ma'am, 5 into 7 into 11 into 13.
Yes, good. Shreya got the answer.
Yes, ma'am.
5 into 7, 11 into 13. You got the answer. 1. So 11 ones 11, 11 threes, 13 ones are 13. Yes, 5 into 7, 11 into 13. Good. Next question is 7429. So it is odd number and you should know by which number you have to divide, okay? So it is not divisible by 2, 3, 5 and 7, right? Is it divisible by 13? No. You have to divide it by 17, children. Seven, 4, 2, 9, right? Four, 3, 7. Three, sir. Next to 23. Okay. You got the answers, Shreya and Panchami. Yes, you have to take 17, 19, 23. Okay. So 17 into 19 into 23. See, just you take the prime numbers. Okay. 3, 5, 7, 11, 13, and then 17, 19, 23. Okay. So you have to check with all the numbers. You got 17, 19 into 23. And next one, you have to find out HCF and LCM. Okay, so in this chapter, you are going to learn only HCF about HCF and LCM and relation between HCF and LCM that I taught in bridge course right now. So, and one more concept, you have to prove the numbers are irrational. Okay, you have only two concepts in this chapter. Let us see how to find out HCF and LCM of given numbers. Okay, 20s, I'll give example. 8 and 12. Okay, you know which is, what is HCF of 8 and 12, right now? So, divide or by listing the numbers, you can, factors you can write. Tell me the factors of 8, 1, 2, 4, and 8. What are the factors of 12? Yes, Shreya?
Ma'am, 1, 2,
1, 2,
3,
3,
4,
4,
6, and 12. Ma'am.
6, and 12. Very good. This we have listed the factors of the given numbers. And what is the next step? Unmute and speak, Panchami and Shreya.
Ma'am, we have to find the common factor.
Yes, which are the common factors here? 1 is common factor, 2 is common factor, then
4, ma'am.
4, only 4 right now. We have 3 common factors here, 1, 2 and 4. So, but which one we have to consider here? Highest common factor. We have listed the common factors 1, 2 and 4, but we need highest. So, which is highest common factor here? 4. Okay. So, HCF is equal to 4. What is LCM? What is LCM here?
Ma'am, it is 1.
What is LCM? Least common
Sorry, ma'am.
multiples. Okay, don't confuse. Least common multiples. Okay, so we have to write the multiples of 8 are 8, 16. Just write the tables. Okay, 32, 40, so on. 48, so on. And write the factors of 12. 12, so on. Okay, so here also mark the common multiples. Which are common multiples here?
Ma'am, 24 and 40.
Yes, 24 is common and 48. Okay, so you can continue with the numbers, but we have two, already we got 2 common multiples. Which are the 2 common multiples? 23, and the next common multiple is 48. And which is LCM here?
124.
24 is LCM. Least common multiple is 24. Okay, but we are here. I'll write the first sum. 26 and 91. Okay, so 26 and 91. So you know to write how to write 26. That is 2 into 13. So what we are doing here by prime factorization methods, we will find the factors and we will write here. No, so same thing I'm doing here. Write 2 into 13. How can you write 91? See, 3 2s are sorry. No, it is not divisible by 3. It is divisible by 13. Right now, so you can write it as 7 into 13. 7 into 13. Understood? No, how to write? If you don't know, you can do in working column and then write the answer here. So here, what is common? 13 is common. So HCF is equal to 13. What is LCM? See, I'll show you what
is
1 second. See, HCF is product of smallest power of each common prime factor. Common prime factor. Okay, see, HCF is product of, see, smallest power of each common prime number. So you have to take smallest, 13 to the power of 1, 13 to the power of 1. See here, 13 is common, right now. So small, we are, see, I am telling you smallest power of each common factor. We are taking the common factor for HCF. Understood? And what is LCM? LCM is, it is also product of, it is also the product, right now, product of greatest power of each prime factors, each prime factor. Okay, see what is the difference between these two? Can you tell me? Did you understand what is it? How to write HCF and LCM from this? You understood what is HCF right now? See, we are taking the smallest power of each common factor. And what is LCM? See here, 13 is common, write 13 and write the remaining numbers also. Which are the remaining numbers? 2 and 7. 13 into 2 into 7 is LCM. Did you understand? We are not taking common factor in LCM. Okay. Common factors we are taking only in HCF. That is equal to 14 into 13
Ma'am, 182.
is 182. LCM is 182. Did you understand this too? Or how to write? Okay, while writing the sum, you will come to know that. Don't worry. So HCF means smallest power of each common factor. It is greatest power of prime factors. Okay. Yes, I'll do the second one. And you have to verify that, right? No. See, what is the relation between HCF and LCM of two numbers? HCF into LCM is equal to product of two numbers. You know that? See, you will find HCF of two numbers and LCM of two numbers. That will be equal to product of the given numbers. For example, in the first sum, we took 26 and 21, right? No. See, what was HCF here? HCF was 13 and LCM was 182. I will substitute here. HCF is 13 into what is LCM? 182 is equal to what are A, B? Given numbers. Which are the given numbers? 26 into 91. So we have left hand side and right hand side. See, will we get same answer or not? Okay. 26. So 2, 3. 2, 3, 6, 6. That is equal to 26 into 91. 6, 2, 23, 6. Yes, 2, 3, 6, 6. 2, 3, 6, 8. See, both LHS and RHS are equal. Got children? See, this is the relation between HCF, LCM and the given numbers. We'll go for the second one. 510 and 92. So express 510 as product of prime factors. So how can you do, find the factors, children, fast? Got the answer? I got the answer.
Yes, ma'am. Good.
Yes. Shreya got the answer?
Yes, ma'am.
Okay. So here, what is HCF? We have only 1, 2, 3, 5. Here we have 2 to the power of 2 into 2 to the power, 23, right now. So What is common here? We have only one number is common, that is 2. So HCF is 2, right now. So what is LCM? What is LCM means? Tell me what is LCM, Shreya? Which numbers will you write from these two? Which numbers?
Ma'am, 2.
Yes. See, I told you, no, for LCM, you have to take greatest power. See, here it is 2 to the power of 2, and here it is 2 to the power of 1. But here, which one you have to take? 2 to the power of 2 or 2 to the power of 1?
Ma'am, 2 to the power of 2.
Yes, okay. So like that, 2 to the power of 2 into, you have to write all remaining numbers. Okay. So we have taken this right now. So tell me the numbers. Continue, Shreya. 2 to the power of 2 into
3 into 5 into 17
huh?
into
Okay.
23.
Very good. Good. So that is equal to, I will write the answer. So you will get 23460. This is LCM of given numbers. Okay, children. And verify the relation HCF into LCM is equal to A into B. What is HCF? HCF is 2. And LCM is 23460 is equal to given numbers. Which are the given numbers? 510 into 92. 510 into 92. Multiply these two. 0, 12, 9, 46,920. 510 into 92. 0 to 10, 9 ones 9, 9 fives 45, 0 2 9 6 4. Right now, children, both LHS and RHS are equal. Yes. Have you taken? You finished Shreya Panchami?
Yes, ma'am.
Okay. And the
Yes.
next one, third one is 336 and 54. Which lesson are they doing in school, Shreya? How many chapters are completed? Shreya.
Ma'am, 2, ma'am.
Okay, which are two chapters?
Ma'am, arithmetic progression and triangles.
Triangles. Okay, what about Panchami?
Ma'am, 3 chapters.
Okay, linear equations, real numbers, and another one is
Ma'am, polynomial.
polynomials. Okay. For Shreya, okay, fine. So 336 and 54. Will you write the prime factors? Write fast, children. Okay, I will also do. You also do. Let me see who will do first.
Ma'am, 2 into 2 into 11.
2 into? Sorry, tell me, Panchami. Once you finish, tell me.
Yes, ma'am.
Yes, ma'am.
Okay. Okay, Panchami, tell me what is HCF here?
Ma'am, 3.
HCF is 3, na? Which are
Sir.
common factors here? We have 2 also, no?
1.
Panchami, tell me what is HCF?
Ma'am, 3. Ma'am, 6, ma'am.
Okay, tell me the definition what I gave you now. It is the product of?
Product of highest common.
No, while writing like this, which one you have to take for HCF?
Ma'am, highest common. 3.
No, it is a product of, we are writing, we are not writing the factor, we are multiplying here, no? So I gave you 2 definitions now, HCF and LCM, no?
Yes, ma'am.
Huh.
Ma'am,
So
product of common factor highest.
yes, we have, for HCF, we have to take a least or greatest.
Ma'am, greatest.
Okay, don't confuse here, which is common factor here 2, no? So smallest power of the common factor. Okay, small, we are taking smallest power. Here we have 2 to the, that's what I'm telling, you should understand the concept. Here we have 2 to the power of 1 and here it is 2 to the power of 4. We have to tell 2 is common, right? No, 2 is common, but for HCF, we have to take the smallest power of common factor. Okay, so you can take only 2, no? You cannot take 2 to the power of 4, right?
Yes, ma'am.
Is it right? Yeah, here we are taking smallest power. So that is 2 into. Here also we have 3 and here it is 3 to the power of 3. Which one you have to consider? Smallest power. So that is 3.
3 to the power.
Yes. Did you understand? That's why I gave you that definitions. So LCM is equal to, it is the product of which one you have to consider now?
Ma'am,
Greatest power. Greatest power. Okay. So greatest power is 2 to the power of 4 into greatest power is 3 to the power of 3 into 7. Did you understand? See, write
Yes.
like this. For HCF, we are taking, see the common factor is 2. But you cannot take 2 to the power of 4, right? No, you know that is only 2. So we are taking the smallest power of common factor for HCF, greatest power for LCM. We are not mentioning common factor. Okay, just the greatest power of the prime number. 2 to the power of 4. Here 3 to the power of 3 is greatest. So write that into 7. See, if you multiply these numbers, you will get 3024. Okay, 3024. And let us check the relation. HCF into LCM is equal to product of the numbers. So HCF is, we got 6 and LCM is 3024. Right, children? Which are the two numbers? 336 into 54. 14 and 18. That is equal to, multiply here, 336 into 54. Can you tell me the answer?
Same answer, ma'am.
You got the same answer. Good. What about Shreya?
Ma'am, I too got the same answer.
Yes. 18144. Okay. Next, third one, third main. Find HCF and LCM by prime factorization method. And here also you have same problems, children. 12, 15 and 21. You have three numbers here. Write the factors of, product of primes. Express 12 as product of primes. How can you write 2 into? Shreya, tell me 2 into? You can write directly, no? Because small numbers. Shreya?
2 into 3.
2 into 2 into 3. 2 2s are 4, 4 3s are 12. Then tell me 15.
3 into 5.
3 into 5. And 21, 3 into 7.
7.
Yes, good. So, which is common here? 3, 3, 3 is common. We have only one common number. So, HCF is equal to 3. Right now? So, what is LCM here? See, LCM means you have to take all the numbers, right? 3 into 5, 3 into 5. So 3 is common. First write the number. Then we have 2 square here. 2 2s are 4. I'll write directly. Then you have to write remaining all the numbers, children. Okay, we are not taking common factors here. So you have to take all the numbers. We have taken common number. A common number should not be repeated. No, like 3 into 3 into 3. Okay, you have to take only once. 3 is common. 2 2s are 4. 5 into 7. That is 420. And you have to, that's it. You have no need to verify that. Just you have to find out HCF and LCM for this main. Okay. Are you understanding? What about Shreya?
Yes, ma'am.
You are
Understood.
understanding, right? Because for Panchami already it is done. If you have any doubts, you can ask me. I'll give you second one. 17, 23 and 29. So how can you already 17 is prime number itself, no? So you can write it as 1 into 17, right? So 17 into 1. What about 23? It is also prime number. You can write directly 23 into 1. What about 29? It is also prime number 29 into 1. So what is common here?
1, ma'am.
1. Very good. So HCF is 1. So all are given, all are prime numbers only. So LCM is equal to, yes, you have to multiply all the numbers. 17 into 23 into 29. If you multiply all these numbers, we get 11,339. Yes. Write the answer, children. Tell me once you finish, children.
Finished, ma'am.
Next one. 8, 9 and 25. Yes. Shreya, tell me, how can you express 8? 8 can be written as?
Ma'am, 2 into 2 into 2.
2 into 2 into 2. What about 9?
3 into 3, ma'am.
25? Unmute
5.
and tell me.
5 into 5.
5 into 5. Very good. What about common factor? Do you have any common factor here?
No, ma'am.
There is no common factor. So HCF is
1, ma'am.
1. What about LCM? What you have to
1.
take all the tell me. What is LCM? Panchami, what is LCM?
Ma'am, 900.
Is it 900? Okay, Shreya, tell me and sorry, do and tell me the answer.
I'm sorry, ma'am, 1800.
Okay.
Ma'am, it is 1,800.
Very good. Okay. 2 2s are 4, 4 2s are 8. 8 into 9 into 25. It is 1800. Yes. And the next one. Fourth one, they have given HCF of 306 and 657 is equal to 9. Find LCM. Okay, tell me how will you find LCM? They have given HCF. We need to find LCM. How? How can we find?
Ma'am, HCF into LCM is equal to product of numbers, ma'am.
Yes, okay, by using the relation. So A into B, and they have given two numbers and HCF. What is HCF here? 9. Substitute LCM plus, is equal to 306 into 657. Yes, LCM is equal to 306 into 657. I'm going to shift this 9 to right hand side. So where does it go? We have 9 into LCM, no? So we have multiplication sign here. So if you shift into right hand side, it comes to denominator, right? So you can cancel 306 by 9. Yes, 34, it divides 34 times. So LCM is equal to, I will write the answer, children. That is, if you multiply 34 into 657, you will get 22,338. Over, right. Over.
Yes, ma'am.
Keep textbooks with you, children, so that you can copy the sum from the textbook. Shreya finished?
Yes, ma'am.
Okay. Okay, next to fifth question. Check whether 6, that is not 6n, that is 6 to the power of n, children. This is 6 to the power, n is power. 6 to the power of n can end with the digit 0 for any natural number n. Did you understand the question? Check whether 6 to the power of n can end with the digit 0 for any natural number n. Say yes or no. Just tell me.
Ma'am, it is no, I think, ma'am.
Yes, very good. See, that is 6 to the power of n. Okay, they are asking, does it end with 0 for any natural? You give the values for n. Okay, so if it is 0, if n is 0, what is the answer? Any number to the power 0, what is the answer?
Ma'am, 1.
Very good, it is 1. Okay, so 6 to the power of 0 is 1. So if n is 1, 6 to the power of 1, that is equal to 6. If n is 2, what is the answer? 6 to the power of, means 6 into 6, right? No, you will get 36. See, if n is equal to 3, 6 to the power of 3, what is the answer? 216. If n is equal to 4, what is the answer? See, if you observe the numbers, we are getting, what are the units placed here? We are getting only 6 right now. So we are not getting 0 at all. Means any other number than 6. We are getting only 6. So, and also you cannot split 6 as 2 into 5 or 3 into 5 like that, right? No. See, when there is, if it is 10 means we were getting, right? No. 10 to the power of 1 is 10. 10 square is 100. Then only we get 0. So here we are not getting 0. So prime factorization of 6 to the power of n does not contain prime number 5. Okay, that means no, we won't get 0 in units place. Did you understand? And next question is, see, explain. I think we have 4 minutes. One second.
Ma'am, can you please repeat the fifth question, ma'am?
Fifth question. Okay. See, we have 6 to the power of n right now. We have 6 to the power of n. Check whether 6 to the power of n can end with the digit 0. Okay, for any natural number n. Did you understand? Check whether 6 to the power of n can end with the digit 0 for any natural number n. See, we cannot split 6 as 3 into 2 to the power of n right now. So we cannot split 6 as multiples of 5 or anywhere. So we won't get 0 in units place. Okay, children, remaining I will continue in the next class. Did you understand how to find out HCF and LCM of the numbers and how to verify the relation?
Yes, ma'am.
Okay, we'll continue in the next class. Okay, keep practicing. Okay, homeworks, practice any 5 sums. Okay, HCF and LCM. Okay, children, keep practicing. We'll continue in the next class. Thank you.